Welcome to section 432. We're going to be talking about circles as we talked about before. So the standard form of a circle, the quantity of x minus h squared plus the quantity of y minus k squared equals r squared. Remember the rules for h and k, you have to switch the signs. And don't forget, it equals radius squared, so you need to take the square root to find the radius. So the center is at hk, the radius is r. So we're going to identify the center. So for the center, it's at h and k. So the center, not at 5, but negative 5, not at negative 3, but 3. And then r squared equals 16. Take the square root of both sides, so the radius is 4. So the center is at negative 5, 3, and the radius is 4. For number 2, the center is at 2, 5. And the radius squared is 20, so we take the square root of both sides. The radius is. Now to simplify the square root of 20, we get the square root of 4, square root of 5. So the radius is 2 square root of 5. That's the exact radius as a simplified radical. Number 4, the center. There is no parentheses for the x, so the h is 0, k is negative 1. Radius squared equals 40. Take the square root of both sides. The radius is. So you get the square root of 4, square root of 10. So the radius is 2 square root of 10. There's our center and radius. And problem number 4. The center, negative 4, negative 7. And the radius squared is 100. When you take the square root, the radius is 10. Just keep in mind that our radius, we're always looking at the positive square root, not the negative, because radius is a distance, and distance is always a positive number. Now to graph, all we need to do is find the center and the radius. So the center is at negative 3, 2. The radius squared is 9. Take the square root of both sides. The radius is 3. So we plot the center, negative 3, 2. And then our radius is 3. From the center, we go up 3, to the left 3, down 3, and to the right 3. And just try to carefully draw a circle through those points. It's not art class. Just try your best. So to go with our domain, all of our values for x are between negative 6 and 0. So negative 6 less than or equal to x less than or equal to 0. And our range, our outputs, our y's are always between 5 and negative 1. So negative 1 less than or equal to x less than or equal to 5. There's our domain and range. On the next page, we're going to sketch again. So we need our center, and that's going to be at 4, 0. The radius squared is 25, so we take the square root. The radius is 5. Over 4, up 0, there's our center. So then we go up 5. We go to the left 5, we go down 5, and to the right 5. And then carefully try to draw our graph through those points. So there's our circle. So our domain, for our x's, we're between negative 1 and 9. Negative 1 less than or equal to x, less than or equal to 9. And our radius, our range, we're going to be between negative 5 and positive 5. Negative 5 less than or equal to y, less than or equal to 5. Now to continue on, we're going to write the equation of a circle. Remember, it's x minus h squared plus y minus k squared equals r squared. The center is hk, and the radius is r. So here, x minus h, which is negative 6 squared, y minus 2 squared equals 5 squared. And then we'll clean it up. it becomes x plus 6 squared, y minus 2 squared equals, and 5 squared is 25. There's the equation of that circle. Number 8, here's our h, our k, and our r. So it's going to be x minus 0 squared plus y minus negative 3 squared equals, and we're going to square the 2 square root of 3. Now, off to the side, when we square a radical expression like this, we want to square both factors. We're going to square the 2 and then square the square root of 3. And we're going to multiply them. So it's going to become 4. And when we square the square root of 3, we get 3. And then 4 times 3 is 12. So it's going to be x squared plus the quantity of y plus 3 squared equals 12. Number 9, x minus 0 squared, y minus 0 squared equals the square root of 6 squared. So it's x squared plus y squared equals 6. There's our equation of the circle in standard form. Last one, x minus negative 3 squared plus y minus negative 5 squared equals 3 squared of 5 squared. So we get x plus 3 squared plus the quantity of y plus 5 squared equals. So we square the 3 and the 5. So 3 squared times the square root of 5 squared. So it's 9 times 5, which is 45. So it equals 45. And there is our answer for the equation of that circle. Now, what we can do is we can rewrite these as well. We're going to rewrite and we're going to change this equation from this form into that equation of a circle form. So what we're going to do that is basically complete the square twice for the x and then for the y's. So I'm going to space everything out. X squared plus 4x, I'm going to leave some space, plus y squared plus 2y, leave some space, equals 11. So I'm going to do my completing the square twice like we did in the last section. So I'm going to be adding the middle term, 4 divided by 2 squared. And then for the y's, I'm going to be adding 2 divided by 2 squared. So we get x squared plus 4x plus 4 plus y squared plus 2y plus 1 equals 11 plus 4 plus 1. So now for the x squared plus 4x plus 4, it's going to be x plus 2 squared. When I factor y squared plus 2y plus 1, I get y plus 1 squared, and that equals 11 plus 4 plus 1, which is 16. There's our equation in that graphing form, that standard form of a circle. So we can easily see that the center is at -2, -1, and the radius, since the r squared is 16, the radius is 4. Let's do another one of those. So now for problem number 12, same thing. I'm going to isolate the x's. I'm going to kind of put them by themselves. X squared minus 4x, leave some space, plus y squared plus 6y. And actually, while I'm at it, I'm going to add 3 to both sides. I'm going to leave some space and put the 3 over here. So I just rewrote and added 3 to both sides. So now, with the x's, I'm going to add the -4 over 2 squared to both sides. And with the y's, I'm going to be adding that 6 over 2 squared to both sides. So we get x squared minus 4x plus 4 plus y squared plus 6y plus 9, and that equals 3 plus 4 plus 9. So when we factor x squared minus 4x plus 4, we get x minus 2 squared. Plus, when I factor y squared plus 6y plus 9, I get y plus 3 squared. And that equals, now 3 plus 4 plus 9 is 16. There's our equation in that graphing form. So what we're going to do is now we're going to find our center, and that's at 2, -3. And our radius, since the radius squared is 16, the radius is 4. And there we go. That's in that nice graphing form. Now, for problem number 13, we're looking for the point of intersection of the following circles. Now, with the intersection of the circles, we could have the two circles intersecting at 2 points. They might intersect at only 1 point, or they might not intersect at all. So we have those 3 options. Or it actually even could just be one circle on top of the other one. Could just be one circle where we'd have an infinite number of points of intersection. So the way this is set up, I'm going to use elimination. And I'm going to get the x squareds to cancel out. So I'm going to multiply the entire bottom equation by -1. So I get x squared plus 4x plus y squared minus 6y minus 12 equals 0. Now my bottom equation, -x squared plus 8x minus y squared plus 6y. I'm going to leave some space. I'm going to put a plus 0 as a placeholder equals 0. Now I can add those two equations together. And what happens that's nice is my x squareds cancel. So I get 12x. Luckily enough, my y squareds cancel. My 6y's cancel. So I get 12x minus 12 equals 0. I can solve that equation. I can add 12 to both sides. So I get 12x equals 12. Divide both sides by 12, and I get x equals 1. Now that I got x equals 1, I'm going to go and substitute back in to one of the equations to find my y. I'm going to go into the top equation. So I'm going to get 1 squared plus 4 times 1 plus y squared minus 6y minus 12 equals 0. So that gives me 1 plus 4 plus y squared minus 6y minus 12 equals 0. So when I clean that up, y squared minus 6y, 1 plus 4 plus -12 is -7 equals 0. Now I ended up with a quadratic. I can factor this quadratic, and when I do, I get y and y. Now to multiply to a -7 and add to a -6, I have a -7 and a +1. So now y minus 7 equals 0 and y plus 1 equals 0. So y equals 7 and y equals -1. That gave us both of our points of intersection. Now our intersection, x is always 1 and y is 7. That's one point of intersection. X is 1 and y is -1. There's my 2 points of intersection. So my graph would look something like this with those 2 points of intersection. Those intersections up here and the point of intersection down here. Now for part B there, we would be graphing them and finding them. It's a little bit messy to graph it. I'm just going to skip that one. We see how to solve it algebraically, and honestly, algebraically is the best way to solve a system. That is it for chapter 4. Thank you, and I will see you in chapter 5.